This meeting is being recorded.
Okay. Good morning, good evening, good afternoon, everyone, wherever you're from. This is Ethan Dix. I'm coming in from Columbus, Ohio, in the U.S., and I've got a little presentation on something I wrote a while back that basically creates displayable QR codes for the Commodore PET. I came up with it because I often exhibit at Vintage Computer Festival East in New Jersey at InfoAge, and I also exhibit at VCF Midwest. And frequently I have Commodore machines with me, and I thought it would be really handy to be able to give people pointers to documentation, to GitHub links, and so on by having in-period displays. Instead of just printing them out and putting them on paper on the table, I could actually have a QR code pop up on the screen. Taking advantage of the quarter block graphics in PETSCI to get a little better information density, because of course a PET can do easily something in a 25 by 25 grid with just using inverse blocks and regular spaces, but this is 4 times the density, so we can get actually quite a few characters, and it looks rather nice. The basic technique is I don't generate the QR code using the 6502. I generate the QR code on some modern platform, a Linux box typically, and then I have an outboard script that's this is all on GitHub that converts an ASCII QR code into the PETSCI graphics, and you literally just load the PETSCI graphics right into screen RAM. So it's even pretty quick. With that, I'll just go through the process slightly. Let me share my screen. All right. So can everybody see the first slide?
I can see your screen, yes.
Excellent. So the basic process is there is a script that runs that takes your input text string, creates an ASCII version of the QR code, and then a second Perl script reads in the ASCII code and directly emits a loadable PET binary program right into address 8000. So it just goes right into the screen, and that's the workflow. The magic happens in the Perl script because it has a translation table, so it basically reads 2 lines at a time from the ASCII graphic, and sort of from the left, the first two columns plus the first 2 rows creates one PETSCI block, and then it moves left to right, top to bottom to encode all the bits as they come along. And there's a bit of extra space injection to format it on the screen. The amount of information you can store based on what size module. The smallest one is the version 1, and that would even fit with using regular inverse characters. Although there's a trick. So modules are when you look at a QR code, when you see the actual pixels of a QR code, those are called modules. So it's the grid size is described as how many modules by how many modules. There is a caveat here because the QR definition, you have to have a border of 4 modules on all sides that is clear, plain, and basically the same brightness as the light color that's you're using in your QR code, so that the algorithm has a border to latch onto to know where the code is. And that complicates things slightly because, of course, with the PET, your border on the screen is always black. So the QR generator does create that border, the sterile border around the QR code as part of the process, but that limits the resolution slightly, and it determines what choices you can make. So, for example, a 21 by 21 module, the actual graphic size is going to be +4 on each side. So it's really 29 by 29 modules, including the sterile border. So that technically wouldn't fit. You can get away with a smaller border. You could do a 2 by 2 border instead of 4 by 4, and it would probably work. Officially, it's 4 by 4. So that's partially why I went to the quarter block graphics. But you can see that you can only encode 17 characters in a version 1 anyway, so it's not very many. Now, moving up, the reasonable sizes you're likely to deal with are probably in the version 2, version 3 range. I've included all the way to version 7 and 8 because while you can display a version 6 code with the border using quarter block graphics. It turns out to be 49 by 49 total modules, and that fits in an 80 by 50 quarter block PET screen. But with the Commodore 64, a future version I want to write for this, you can leverage the fact that the border color is controllable. So you could make the actual border of the non-screen RAM using a color register be your sterile border, and you could go to a larger size, including up to 49 by 49, which would be 192 characters on a version 8. So that was just sort of a future. The last two items would be for Commodore 64 use. But version 6, 134 characters is a lot of information on a QR code, because that is a version 6 PET displayed QR code screenshot from Vice. And if anybody wants to take a minute to hold their phone up to the screen and translate that, you'll see it's got just a random text string I put in there just to test the principle. I'll give it a couple seconds here. And with that, I'll just show how the process works. Okay. So this is my local copy of the of my repository, and it's got a bunch of extra files in here just to show off. The actual program to generate the codes is very simple. And to do that, we would do let's try this. Okay. So that's it. I've now got a program. Is that right? Should be right. And you can see here from the hex dump, it starts off with 0080 in low byte order. So that's the load address, and then the rest are the characters. And A0, as you might remember, is the inverse space. So with this, I can use Vice and there it is. So that's literally how it's generated, and it's as easy as just loading the file, and it loads directly into screen memory. And one fun thing is one can also even do it from the machine language monitor, because it's just a binary. So that's pretty much the walkthrough, and I'm hoping to, at the next VCF in Chicago this fall, have some of these running at my table. So when somebody comes up, I can either hit a key, or a program might start up, display the code, and then somebody can take a snapshot of it and then go on to run the code and show where the code comes from. And at this point, I can take questions.
Great, many thanks, Ethan. Yes, I don't know if there are any questions. Let me check in the chat.
I see one in the chat. I did not write an Amiga tool. For Amigas, you can just literally generate a PNG file or a GIF file and then just load it. So the QR code generator can emit graphical formats. I chose to use ASCII because I happen to be a Perl programmer, and it was just easiest and simplest to take an ASCII format QR code and um, display the or read the text in and process the text. Actually, yeah. So let me real quick. If I'm still sharing the screen, I think I am.
You're not actually.
I'm not anymore. Okay. So I was just going to quickly show off the Perl script. There you go. So after the table, it basically just, it's a pretty simple loop to read the file in. So it literally just chews on the ASCII file. Because the QR code generator does double lines to make the box square, it has to discard every other line. So there's in the ASCII output, there's duplicate lines. So it dedupes the lines. And because it's likely to be an odd number of lines, there's a little bit of code to handle the fact that it might do a read and it might be looking for the second line, and it might be the first line might be blank and the second line might not be there at all because it may be an odd number. So there's a little bit of code to handle that case. But more or less, it reads it in, automatically figures out how many lines there are, which will advise what screen width it has to fit in, which is how it calculates the padding to know when it's wrapping around, writing into memory bytes, how to get everything aligned vertically from line to line. And then sort of the magic substitution all happens down in here, where it grabs the pixels, converts them one by one. So the point is that for an Amiga, you wouldn't have to do any of this work. You could just directly go to a graphic.
Yeah, thank you. You mentioned at some point making a Commodore 64 version. Do you plan to do one version for each computer from Commodore, or what's the?
Well, I mean, mostly this is kind of, it's for 8-bit machines. The primary screens would be original PET, 80 column PET, VIC-20, and then Commodore 64 / Commodore 128 would be the basic platforms. And the reason for that would be, of course, the VIC-20 has a lower resolution, so that would limit which version you could display as a maximum size. You can still do a lot. A VIC-20 with quarter block graphics, you can still pack 44 elements in. So you can get a decent size QR code on a VIC-20 screen. And then, of course, with the VIC-20, like the Commodore 64, you can leverage changing the background border color and so on. So because the literal display implementations are different, there's going to be a possibility of 3 or 4 versions just in the arena of Commodore 8-bit machines.
Okay, so it's definitely good enough to host, to embed the link to Commodore Users Europe website, which is quite short.
And I will go ahead and put the QR code. I know it was in the bit, but here's I've pasted the GitHub link into chat for anybody who wants to have a look. It's a handful of files. It's very easy to use. The GitHub has several screen examples, so it's pretty explanatory. And again, the code is pretty basic.
Great. Many thanks for that.
Absolutely.
I don't see currently more questions, but so I invited people to maybe post the questions there if they still have it. And then I will stop the recording. Many thanks again, Ethan.
Absolutely.